Hello everyone. So we had finished last day with the chapter called solution. Now we are going to move to the next chapter, that is electrochemistry. Now before starting this particular chapter, let me just tell my experience as a student and as a teacher. When I was a student, I felt this chapter as the toughest chapter because it's very, what at that particular time when I was the student, I found it very difficult to understand. That's partially because of my negligence and partially because of the teaching quality. Okay, that I should not speak, but anyway, that was the reason. So let me be truthful enough. But this chapter is actually the easiest chapter if you understand it properly. So your main focus over here will be understanding. If you understand it and do whatever I am saying to do, then you will find that you don't even have to study this particular chapter. You are ready with this chapter without studying the chapter. So the understanding part is very, very important. So you must understand it. You must understand it. Okay. So that's the first thing about this chapter I must tell you. Now we are going to start with this chapter. Now electrochemistry. Obviously this is the branch of chemistry where we deal with the interconversion of electrical energy into chemical energy. Interconversion means what? The conversion of electrical to chemical or from chemical to electrical energy. That is what is studied in this particular chapter. Now, what do you understand by electrical to chemical energy? Now, there are certain chemical reactions which are not taking place normally. For example, suppose if I add hydrogen and oxygen, 2 moles of hydrogen and 1 mole of oxygen, nothing will happen. They will just add and will form a mixture. But if in that mixture I add some electric spark, I just apply some electric spark, means I pass the electricity to it, then it will convert into 2 moles of water. So this particular chemical reaction is taking place only due to electric energy. Okay, so here the chemical energy is happening, or the electrical energy you can say is converted into what? Is converted into chemical energy. Electrical energy is converted into chemical energy. Whereas in certain other cases, for example, suppose anything, okay, suppose some battery. What is happening over there? Some chemical reactions are taking place in the battery. And because of those chemical reactions, some electricity is generated. So in that particular case, the chemical energy is converted into the electrical energy. Here, in this particular chapter, we are studying this interconversion of electrical and chemical energy. The device, the instrument where the chemical energy is converted into electrical energy, as I told, the battery, the simple words, the normal words, we say the battery. If the chemical energy is converted into the electrical energy, that particular device is known as electrochemical cell. We call it electrochemical cell. Okay, and the device in which some chemical reactions are taking place with the application of electricity. If we pass the electricity, some unwanted chemical reaction takes place, then those particular devices are called electrolytic cell. So two devices, electrochemical cell and electrolytic cell. What is electrochemical cell? Electrochemical cells are those devices where the chemical energy is converted into the electrical energy. And what is electrolytic cell? These are those devices where the electrical energy is converted into the chemical energy, right? This is what in detail we are going to study in this particular chapter. Clear? Now before going to any further, first of all we must understand some basic terms which we already know I'm just going to recap it, and you must know it. In the first class of electrochemistry, we must do with this. Okay. The first term we must know is conductor. Now, what is conductor? Obviously, whenever I am talking of conductor, I am talking of electrical conductor. Certainly, I am not talking of bus conductor. Electrical conductor. Okay. So, what is electrical conductor? The substance which passes or through which the electricity is passed. The substance through which the electricity is passed are called the electrical conductor. Now, this electrical conductor can be of two types. One type, the common one which you know, are called the metallic conductor. Or these are also called electronic conductor. Metallic conductors are also known as electronic conductor. You know why metallic conductors are known as electronic conductor? Because in metallic conductor, the conduction of electricity is due to the flow of electrons. That is why metallic conductors are also called the electronic conductors, which is commonly used conductors are the metallic conductors. And second type are called the ionic conductor. Or these are also called the electrolytes. Ionic conductors. Ionic conductors means what? Where ions are responsible for the conduction of electricity. Here the electrons are responsible. Here the ions, it may be the positive ion, it may be the negative ion, cation, anion, anything. Those conductors are called electrolytes. I hope you know this term already. So we will come to that term, but first let us finish with the metallic conductor. Metallic conductor means any metals which are conducting the electricity, and they are conducting electricity because of the flow of the electrons. Okay. Now, this metallic conductor, one thing, some properties of metallic conductor, properties of metallic conductor. First property, there is some differences between the metallic conductor and ionic conductor, so you can understand that. The first one is it is not changed while conducting the electricity. Suppose some copper wire is there and the electricity is passed. After 100 years also that copper will remain same. So there is no change during the passage of electricity. That's the first point, right? Second point, you will be very surprised to know that it conducts low electricity. It's a low conductor, or it's a poor I should not say. It is less conductor. Less conductor in comparison to what? In comparison to the ionic conductor. Ionic conductor conducts more electricity than the metallic conductor. Ionic conductor conducts more electricity than the metallic conductor. And the third point is that with the increase in temperature, as you studied in physics also, with the increase in temperature, the resistance of this conductor increases. And if the resistance increases, obviously the conductance will decrease. That means it will conduct less amount of electricity. Okay, if at a higher temperature, when the temperature is hot, the metal wires, the metal conductors, the metallic conductors, or the electronic conductors are conducting lesser amount of electricity. So these are the main properties of what? Main properties of the metallic conductor. Now we are coming to ionic conductors. In case of ionic conductors or electrolytes, first of all, electrolytes can be of two types. What are the two types of electrolytes? Okay, first of all, what are electrolytes? Electrolytes are the substances, are the chemicals which are broken down. Dissociated means broken down into the positive and negative ions, either in the molten state or in the aqueous solution state. For example, if I write NaCl liquid or NaCl aqueous, then they are electrolytes. Certainly not NaCl solid. That's not an electrolyte. Why that's not an electrolyte? Because in solid condition it's not getting dissociated or broken down into ions. But in liquid condition, means if we melt sodium chloride, it will break down into Na positive and Cl negative ions. If we take it in aqueous solution, it will break down into Na positive and Cl negative ions, and in that particular case they will act as what? They will act as electrolyte, they will act as ionic conductor, they will conduct electricity. So what is electrolyte? These are the chemical substances which dissociates into the corresponding ions, the positive and the negative, either in the molten state or in its aqueous solution. That's electrolyte. Now electrolytes can be of two types. Electrolytes can be of two types. One we call strong electrolyte, another one we call weak electrolyte. What are strong electrolytes? The electrolytes which are almost completely dissociated. Almost completely dissociated. Almost is a very important word. Nothing is completely dissociated. Almost completely dissociated are called strong electrolytes. For example, sodium chloride. If I take suppose 100 sodium chlorides, out of 100 sodium chlorides, maybe 99 will get dissociated and 1 will remain as sodium chloride. Okay, 99 will dissociate into sodium positive and chloride negative, and 1 will remain as sodium chloride. So that's an example of what? That's an example of strong electrolyte. Whereas weak electrolytes are what? Where the dissociation is partial. For example, suppose CH3COOH, acetic acid. When it dissociates acetic acid, it is broken down into H positive plus CH3CO negative acetate ion and a hydrogen ion. But the amount of dissociation will be very partial. Okay, that means around 60-70% of this will be dissociated under normal condition. Okay, those are called weak electrolytes. Does that mean that any chemical are electrolytes? Are all the chemicals dissociated in the molten state or aqueous solution? No. There are so many chemicals. Which remains undissociated in all conditions. Those are called, another term, those are called non-electrolytes. These non-electrolytes are not at all responsible for the flow of electricity. They cannot flow or cannot allow the flow of electricity. For example, sugar, okay, chini, okay, for example, whatever, okay, glucose. There are so many. These are the example of what? These are the example of non-electrolytes. Fine. Okay, so you understood what is electrolytes. Now, what are the properties of electrolytes? We know the properties of the metallic one. Now, what are the properties of electrolytes? First of all, these are strong. Strong means it is comparatively stronger than the metallic conductors, better conductors than the metallic conductors. That is the first thing. Second thing, that if we increase the temperature, that's the important point. If we increase the temperature, the resistance will decrease. Just opposite as that of the metallic conductor. Resistance will decrease if we increase the temperature. Okay. Now, if the resistance decreases, obviously more amount of electricity will flow. So, if we increase the temperature, the amount of electricity that will be flowing is more. Okay, let us explain it now. Why it is so, whereas in case of metallic conductor it is opposite. Why in this case it is so? So let us just try to understand it. It's very simple. Again, suppose I am taking an example and I am trying to explain it to you. Sodium chloride only. Let me take the sodium chloride aqueous solution. So you have taken some water molecule is there. And in that I had added some sodium chloride, which is dissociated as Na positive and Cl negative, like that. So many of them are there. Okay, fine. Now at this condition of the solution, there are three types of force of interaction, I should say, which is taking place. What are the three types of force of interaction? The first one is ion-ion interaction. Ion-ion interaction. The ions in between them are interacting. Means there is a kind of force of attraction between the ions. Okay. Next type is ion-solvent interaction. Ion-solvent interaction. What is ion-solvent interaction? The ions are interacting with the water molecule. Okay. And the third type is solvent interaction. Solvent interaction. These are the three types of interaction that is taking place in this aqueous solution. Now if we increase the temperature, if the temperature is increased, all these force of attraction decreases. All this force of attraction decreases. The ion-ion interaction becomes less. The ion-solvent interaction becomes less. The solvent-solvent interaction becomes less. And hence the movement of the ion becomes faster and easier. The movement of the ions become faster and easier. And the electricity is due to the movement of the ions only. That is why they are called ionic conductor. So since with the increase in temperature, the movement of the ions is becoming easier, what will happen to its conductance? Its conductance will obviously increase and hence its resistance will decrease, which is just opposite to that of what? Which is just opposite to that of the metallic conductor. Is it clear? Yes. Very good. So that's what is conductor is. The first part, conductor. The first term we have come to know is conductor. Okay. Next is resistance. Hope you know this already. Resistance. Resistance, which we denote by R. This thing, obviously resistance is what? It is the force by which the flow of electricity is opposed by the conductor. It is the force by which the flow of electricity is opposed by the conductor. You know it. Okay. Fine. Now, this is coming from the law called Ohm's law. All of you know this. That V is proportional to I. Yes. Therefore, V is equal to what? Therefore, V is equal to I into R. Okay. So, all of you know this equation. All of you know Ohm's law. And the R is what? R is resistance. What we have to know now is that what is the unit of R? Since it is Ohm's law, the unit of R is Ohm. We write it like this, Ohm, or we can write it like this also, Ohm. Okay, fine. That is omega actually. Okay, Ohm. So these are the unit of, this is the unit of resistance. Fine. Okay, all of us know this. What is resistance? Fine. Now the next one is conductance. The next term we must know is conductance. Conductance. Conductance is generally denoted by either C or it is also denoted by G in certain book. It's nothing but what is conductance? How much of electricity is flown or how the electricity is flown in through the conductor. Okay, as much as the electricity is flown, the conductance is more. That is what we know. Now it's actually just the reciprocal, just the opposite of resistance. Resistance is obstructing it. Conductance is flowing it. So mathematically conductance is nothing but, it's nothing but the reciprocal of resistance. It's nothing but the reciprocal of resistance. So that is nothing but 1 by R. So the unit of this will be simply, we write it like this, Ohm inverse, Ohm to the power minus 1 by Ohm. Okay, or we write it like this, Ohm inverse, or we also write like this, you know, we write like this MHO. Just we write Ohm from the opposite direction, Mo we write. Or this has got also another unit. The same thing is represented by also Simon. Okay, Simon. Okay, so Simon is what? Simon is, well, actually the name of the scientist, Simon, or Mo, or Ohm inverse. Ohm inverse is the unit of what? Is the unit of conductance. All are same only. There is no difference in it. Okay, exactly same. That's the second term we know. Now the third term, resistivity or specific resistance. Resistivity or specific resistance. Third term, specific resistance or resistivity, which is denoted by rho. Which is denoted by rho. Okay, what we know is that R, that is resistance, is directly proportional to the length of the conductor. More the length, more is the resistance. And we also know, this you already know, we also know that is it inversely proportional to the area of cross section, 1 by A. So can we write R is equal to some constant into L by A? Okay, and that constant is nothing but the specific resistance or resistivity. So rho into L by A. So this rho is what? This just mathematically I told. This rho is what? This rho is nothing but specific resistance or resistivity. Okay, so what is specific resistance or resistivity in words? How can we say this? How can we know it physically? What is that? See, we're just putting some condition at L equal to 1, A equal to 1. What does it mean? At L equal to 1, A equal to 1. What is the meaning of that? Physical meaning of that? That the length of the conductor is 1 and the area of cross section of the conductor is 1. So we are talking something like this, okay, whose length is suppose 1 centimeter and area of cross section is also 1 centimeter, okay, 1 centimeter square, okay. Find if L is equal to 1, A is equal to 1, can I say R is equal to rho? Yes. Now this rho only we are going to define. What is rho? That is specific resistance is nothing but resistance of a conductor. What type of conductor? Whose length is 1 and cross sectional area is 1. Whose length and cross sectional area both are unit. Then we call that resistance as the specific resistance. So mathematically can I say that rho is equal to R into A by L? Can I write it? Rho is equal to R into A by L. Yes, so that we can find out the unit of it. What is the unit of R? Unit of R is ohm. We know this, ohm. Okay. Suppose in CGS system we are doing. So what is the unit of cross sectional area? Centimeter square divided by centimeter. So centimeter square divided by centimeter is centimeter. So the unit of rho is ohm centimeter. But that's CGS system unit. And what will be the unit in SI form? Ohm, obviously meter. And what should be their relation? Ohm meter and ohm centimeter inverse. If I write 1 ohm meter, you can write it like this also. Ohm meter, you know it, should be equal to 1 meter equal to 100 centimeter. Ohm is remaining same, so it should be equal to 100 ohm centimeter. Is it specific resistance or resistivity? Fine. Okay. Now we are coming to the next term, that is conductivity. That is conductivity or specific conductance. Conductivity or specific conductance. Number 4. Conductivity or we also call it specific conductance. And we denote it by kappa. We denote it by kappa. Kappa is written like this, okay? What is this? This is nothing but the reciprocal of resistivity. As conductance is reciprocal of resistance, conductivity or specific conductance is reciprocal of resistivity or specific resistance. So kappa, mathematically, first let us write mathematically, then automatically we will understand, is nothing but 1 by rho. Okay? So what is 1 by rho? Let us write it mathematically first. What is 1 by rho? Rho is equal to what? Rho is equal to R into A by L. So 1 by rho is 1 by R into L by A. Yes? Yes? Okay. Now what is 1 by R? 1 by R is conductance. Conductance means it's the reciprocal of resistance. Okay, so you can write it as C into L by A. What is the unit now? Let us come to the unit. Unit of conductance is what? Ohm inverse. Ohm inverse. This, if I write in CGS system, this is centimeter, this is centimeter square. So centimeter divided by centimeter square is what? That is centimeter inverse. So in CGS system, this is ohm inverse, centimeter inverse. Or you can write ohm inverse, you can write like this, ohm inverse, centimeter inverse, or we can write mho, centimeter inverse, or we can write Simon, centimeter inverse. These are all unit of what? All unit of conductance only, so you can write anything over there. Okay, centimeter inverse. Okay, now if we convert it into SI unit, or what should be the SI unit then? SI unit should be ohm inverse meter inverse. Now what should be the relationship between them now? Now 1 meter equal to 100 centimeter. 1 meter equal to 100 centimeter. That means 1 centimeter inverse should be equal to 100 meter inverse. 1 centimeter inverse should be equal to 100 meter inverse. Hope you understood that. So what is that? 1 meter equal to 100 centimeters. So it's very simple. So I'm just getting this 100 over here, getting this 100 over here, and getting this centimeter over here, centimeter over here, and getting this meter over here. I'm going to get it like this, 1 by meter. So what is this? 1 by 100 centimeter inverse equal to meter inverse. So that is equal to 1 centimeter inverse equal to 100 meter inverse. Can I write it? Okay. So 1 centimeter inverse equal to 100 meter inverse. So 1 ohm centimeter, 1 ohm inverse centimeter inverse equal to 100 ohm inverse meter inverse. That is the relationship between the SI unit and the CGS system of conductivity or specific conductance. So you understood that one also. So what is specific conductance? Now let us know it physically. Physically, what is specific conductance? Same way. If L is equal to 1, if L is equal to 1, A is equal to 1. If L is equal to 1, A is equal to 1, kappa is equal to what? Kappa is equal to C. So it's nothing but conductivity or specific conductivity. Specific conductance is nothing but the conductance of a conductor. It's nothing but the conductance of a conductor whose length is 1 and area of cross section is 1, which has got unit length and unit cross sectional area. The conductance of that is called the specific conductance or conductivity. Yes, is it clear? Okay, so that is conductance or specific conductivity. Okay, now next, the last term for today we are going to know is the molar conductivity. That is number 5, molar conductivity. So what is specific conductance or conductivity? You can understand that. Okay, next one, number 5 is molar conductivity. Molar conductivity. Okay, which we denote by lambda, and this lambda is actually capital lambda. Okay, lambda, capital lambda. Okay, before coming to molar conductivity, let me just clarify a little bit more the conductivity or specific conductance. So what is specific conductance? So when the length of the conductor is 1 centimeter and cross sectional area of is 1 centimeter square, some electrolyte is kept. Now you should start thinking that it is not always metal. It can be some solution of electrolyte also. Some electrolyte is kept in it, and if we can measure the conductance of it, the area of this is 1 centimeter square, the length is 1 centimeter, and hence if we can measure the conductance of it, that is nothing but rho. Yes, okay. Here what is fixed? The length is fixed, area of cross section is fixed. How much of conductance is there is immaterial. How much of electrolyte is there is immaterial. Okay. How much means how much solute is there, how much solvent is there, what is the concentration of the electrolyte, immaterial. Whatever is given, you can find out the specific conductance of it. But molar conductivity is what you know. Molar conductivity is now that we have to place the electrolyte in between two electrodes. In between two electrodes, all of you know electrodes, anode and cathode. In between two electrodes, okay, how much? We have to keep 1 mole of an electrolyte in between two electrodes, and they must be separated by 1 centimeter. They must be separated by 1 centimeter. If we measure the conductance of it, then it is called the molar conductivity. So what is molar conductivity? We will understand it better in the next class when we will compare between these two. But at this moment you must have the basic idea of it. So what is molar conductivity? The molar conductivity is the conductance of an electrolyte. Conductance of an electrolyte. How much electrolyte? Conductance of 1 mole of an electrolyte placed between two electrodes 1 centimeter apart. Here the cross sectional area is not fixed. Only the length is fixed, not the cross sectional area. Yes. Mathematically, we can write lambda equal to kappa by C. Lambda is equal to kappa by C. Okay, what is kappa? Kappa is specific conductance or conductivity, C is concentration. If the concentration is kept in molarity, this particular equation converts into, you please know it because we need it for the numericals. This particular equation is known as lambda is equal to 1000 kappa by m. I am writing this, m is molarity, 1000 kappa by m. Only thing you must be careful of that, here the unit of lambda should be in CGS system, because I had already added 1000, so it should be in CGS system. So hope you understood. Let's recap it. Hope you understood the basic terms of electrochemistry. Okay. First of all, what is electrochemistry? It's the branch of chemistry where we deal with the interconversion of electric current or electric energy and chemical energy. If the chemical energy is converted into electrical energy, the device is known as electrochemical cell. And if the electrical energy is converted into chemical energy, the device is known as electrolytic cell. Okay, first of all. Then about the conductance. First is conductor. The conductor can be of two types, metallic conductor or electronic conductor, because the electrons are involved over here. And the second one is electrolytes, or the ionic conductors, because ions are involved over here for the conductance. Metallic conductors resistance increases with what? Metallic conductors resistance increases with temperature, as we know already. But ionic conductors resistance increases with or decreases with temperature. The conductance increases with temperature, resistance decreases with temperature. Why? Because there are three factors that are involved. One is ion-ion interaction, one is ion-solvent interaction, and thirdly solvent-solvent interaction. All these three factors decreases if the temperature is increased, and hence the conductance increases. Okay. Then electrolytes can be of two types, strong, weak, and the substances which are non-electrolytes are also there. Next comes is resistance. You know Ohm's law, from there you know the resistance, you must know the unit of it. Next is conductance, which is nothing but the reciprocal of resistance. Again you have to know the unit of it. Next one is resistivity or specific resistance, which is denoted by rho, which is nothing but the resistance of a conductor having unit length and unit cross-sectional area. Okay, it's unit you have to know, the interconversion of unit between the CGS system and the SI unit you must know. Next is conductivity or specific conductance, which is nothing but the reciprocal of resistance denoted by kappa, its unit, CGS system, and SI unit conversion you must know. And finally we had come to know about molar conductivity, which is the conductance of 1 mole of an electrolyte placed between two electrodes 1 centimeter apart, and it is denoted by lambda, and its mathematical formulation is, as I told, lambda is equal to kappa by C, or if we express the C in molarity, it will be lambda is equal to 1000 kappa by capital M. Okay, so this is what we are going to do with today's class. Okay, we will move forward with this particular thing in detail. Obviously everything I want to know about electrochemistry. Okay, but beforehand, first thing you must understand that what are the basic terms. Next day we will solve some numericals related to this, and then we will move forward. Till then, goodbye, stay safe, stay healthy. Thank you.